Okay, so I think we can start now. Hopefully everyone has joined. So again, welcome and thank you for joining. I will be your host today. My name is Gorka and I'm a product owner for the storage team here at RatedPower. And today we will be reviewing our latest feature for the best product of RatedPower. Before starting, super quick ad will be the hosting an event, Pulse, the days 3rd and 4th of April of this year in the CON venue here in Madrid. It will be an event full of super top speakers with um, talks about renewable energy and renewable energy sector. So yeah, you're already welcome to join. You can still buy tickets. So hurry up because they'll finish for sure. Well, let's get right into it. So today we'll be reviewing as I said, the best arbitrage feature. We'll be seeing what is the feature about, how does it work, which are its benefits. We'll do a quick demo and Q&A session at the end. So let's start. What is the feature about? So the objective of this feature is very simple, straightforward. It's to allow the users to study the profitability of their best projects. This is a feature available currently for standalone and AC couple best designs. It's not yet available for DC couple. This will be released at the end of this quarter, so we'll have all of them available this year. Um, this is a feature that basically calculates the energy charge and discharge of the batteries. Um, it calculates the total costs, CapEx and OpEx, calculates the revenues obtained from the discharge of the batteries, and also calculates the expenses if you have from charging the batteries from the grid. So if you have a standalone system, you for sure have these expenses. If you have a hybrid system, you may or may not have these expenses. And with all of this, we calculate some energy and financial KPIs so you can analyze the profitability and the overall performance of your system. So, how does it work? So, the tool, the feature provides a techno-economic analysis of the battery system, in which the dispatch decisions are based on an energy arbitrage strategy. This means that the charge and discharge of the battery will be based on price signals, so energy price signals. So what the model is going to try to do and optimize is to basically charge when the prices are the lowest and discharge when the prices are the highest. If you have a hybrid system and you have pre-production and you have maybe curtailment because you have a limitation at the point of interconnection, the model will take all these things into account, but ultimately always trying to, yeah, uh, base the decisions on on the energy prices. We'll do this with the user inputs of the cost of the system. So again, capex and opex, the energy prices in an early basis. Then the cycling parameters of the battery, like the number of cycles per day, the efficiency, the state of charge, and so on. And last, the degradation of the batteries. We will take all these inputs, all this information, and optimize to obtain the maximum profit. So it's again based on this arbitrage strategy, based on the price signal with all these inputs, with all these variables and restrictions, take them all and automatically optimize the charge and discharge to basically obtain the maximum profit out of the system. And with this, we then provide the user with a detailed financial analysis based on all the inputs, financial and also like energy. You will be able to see also you later, but you'll see like all the hourly inputs and outputs and the energy exchange, and it's super cool. Um, which are the benefits of the feature? First, we think it's a super intuitive feature. You can model very complex scenarios that consider, as I said, a great number of variables and restrictions, and all of this with few simple and intuitive inputs that we'll see in a minute. It's also accurate. We decided to go with an optimization approach. There's other softwares in the market that currently follow a more analytical approach, but we decided to go for an optimization approach because we think it's what really replicates what's happening in those trading desks, and basically when you're trading with that battery and operating with the battery, trying to maximize the profit, well, that's what we're doing with this optimization approach, which we think is the most realistic and bankable way of doing this optimization. And last, it's a flexible solution because you have lots of customization available within just a few clicks. Sorry. You can define the different energy prices, the different cycling, and all these variables that define your your use case or your case scenario, and then iterate over and over until you find the one that best like suits your needs. So enough talking. I think we've done a quick intro for what's the feature, how does it work, and the benefits. But I think the most interesting is to really see it in action and see what's capable of. So let me go into the software that I have here open, and let's see step by step what are the inputs and what do you need to run a simulation. So first, well, we have here a standalone system. After we'll see the hybrid one, but let's start with this. First, in the financial section, you have the capex. With these capex figures, these are taken from the National Renewable Energy Laboratory, which is from the United States, that they post yearly analysis of what the general and the global prices for the batteries, and we've taken all of them and put it here. They are public, so you can check them out. This is the source of these prices. You can define the OPEX, the operational cost. Well, it's in US dollars, but you can change the currency from the settings. It's for BESS capacity. You can define the OPEX by power for the battery area. You can also define the fixed cost, and you can define an escalation factor that will be applied year to year to these figures here. And then you have the revenue. Within our case, in this case, as it is a standalone system, you need a variable price. Obviously, that changes hour by hour, so you can leverage that difference while charging and discharging. I loaded here this example file. These are the wholesale market prices, energy prices for Spain for last year, 2024. We can see the details here. You have the maximum price, what is in US dollars, but doesn't matter for the example. It's maximum, minimum prices. You have the average, and you have the spread. This is the important one because this is what will give us an idea. This is a very good indicator to see what price difference we can leverage from that charge and discharge for the battery. We're using this one, but you can upload your own energy prices if you have a forecast, maybe provided by a consulting firm, or anyone, or maybe housemate, I don't know. You can upload them here in different formats. You can do 12 months by 24 hours. You can do for each hour of the year, and you can do for each hour of the year for 50 years, which is the maximum that we can simulate, which I think is enough for a battery system, right? um, Escalation factor also for the revenue and for the energy prices. And last, here we have the discount rate. This is for the financial analysis. And then in the battery part, for the dispatch inputs, we have the runtime efficiency of the battery. This considers the losses from the interconnection or the injection point to the battery, and from the battery back to the injection point, so the whole trip. Then we have the battery cycling inputs with the initial state of charge that sets the initial charge of the battery for the first hour of the simulation. And then you have the maximum and minimum state of charge, which defines the depth of discharge of the battery, which in this case, in this example, is 100%. And then last, we have the cycles per day, or the maximum number of cycles per day. That's going to limit the amount of cycles that of charge and discharge that we can do, that the battery is allowed to do in a day. And then you have the degradation, which is currently linear, and is applied year by year, the same amount. And then you have the end of life state of health, which is set to 65 by default. This is the degradation point up upon the which we consider like the limit. So if the capacity, the battery, sorry, starts with 100% capacity, each year degrades 2%. It goes degrading each year 2% until it reaches 65%. And at this point, we consider that the battery is dead and the simulation stops. So yeah, those are the inputs. Let's change, for example, this to 50, because why not? We can start with the battery half full, and let's run the simulation so we can see some of the results. Great, so it's finished, and now you can see here some of the outputs. You can see the rated power of the system, which is a good amount, best capacity, the supply duration that I didn't go through it because this is another topic, and we've seen it before in previous webinars. So maybe you want to go check it out, but you can define these requirements in those other tabs. You can define the storage inverter, the capacity of the container, the requirements, and the hours, and so on. But the important part here is the battery energy, where you can see like the total energy discharge over the lifespan of the battery. You can see the discharge to grid in a year, how much energy you've consumed, the average capture spread. This is a good one because you can see of that spread that we spoke about at the start, which you can see here, which is 71. We are able to capture 50.74, which it's quite all right, considering the runtime efficiency that we have, and that we have more than one supply hour duration. The average daily cycles that we've done at the end of the year, and the battery lifespan. So with the degradation and the end of life that we've defined, the battery runs for 21 years before being unavailable. You can also download a lot of documentation that is generated automatically, but we're going to check them out. We're going to check out only the energy yield results, which shows the the energy exchange in an hourly basis. So let me open this. Okay, here you see hour by hour the exchange of energy of the battery. So this is very good. I like to do this to quickly check when it's charging and discharging, and you see how well, this is in Portuguese, I don't know why. But you see the price of the energy when it's higher, it discharges, which is this column here. It's discharging, it starts, remember how we set that to 50%, the initial charge. So you see here how it is discharging when the prices are higher. Sorry, this is the energy stored in the battery, and this is the actual discharge to the grid. So you see how it is discharging when prices are higher, and it has still charge in the battery, and then how it charges when the prices are lower, and how it discharges again when the prices are higher. You can also take a look at this table right here when you see the energy discharge to the battery and energy charge. So you see here the tendency of the market of how the prices are much lower during these early hours of the day, and then at noon and midday, and is when the battery is charging. And then you can see where the prices are usually higher during the morning and in the evening, and that's when the battery is going to discharge. So this is one of the documents. We also have the financial analysis. I will show you quickly before going into the next use cases. So let's open this one. And you can see here all the different figures. By the way, I didn't mention the really bad financial numbers that we're getting here. Obviously, it's not very profitable with the current prices of the batteries and energy prices of the last year here in Spain to install batteries. So at the moment, maybe we need some kind of subsidiaries, which is what or capacity payment, which is what the government here in Spain is working for in order to achieve this profitability of the batteries, so developers can start installing them in the system. But you can see here the revenue, capex and opex, and all the different figures. You can see the some plots here, some graphs to analyze everything. You have also the hourly revenue. If you want to check it out with the revenues and the expenses, and also the capex and opex. Right. So now let's go to the hybrid cases. So let's figure out a case where we have, maybe not that one, this one. Okay. So first use case, we have, imagine that we have a scenario with super high curtailment, right? We have a lot of limitation in the point of interconnection, so we want to install batteries to use this curtailment to be able to charge this curtailment into the battery and discharge when the pre-production stops, so we can actually inject some energy, because otherwise we will be losing all of it, right? So in this case, let's set some curtailment here at the delivery point. We have 22 megas, so let's set this to, for example, I don't know, 16, maybe super high, but for the example. And then in the financial, you see this new input, which let us define different energy prices for batteries. Right now, we don't want this. we are assuming that we have a PPA sign, for example, and we are selling all the energy at a fixed price, but we have this curtailment restriction, and we want to charge the battery with this curtailment and then discharge it. So I think with these inputs, we're good to go. We don't want to charge from grid, right? So this is a new input. Also in the hybrid systems, you see that everything stays the same except for this new input that lets us charge energy to the battery from the grid. We don't want this for this example. So let's run the design and see what are the results. Okay, so here we have them. You see the battery energy section, how much energy we've charged from PV, how much energy we've consumed from the grid, it's 0. So that's okay. How much energy we've discharged, again, the average cycles per day, lifespan, and we have here a new KPI, which is the amount of energy recovered from the curtailment. It is a bit low, I would say. This probably means that we need to set a higher or a bigger storage inverter so we can take advantage of it and actually be able to recover all that energy from the PV. So if we take a look at the results, we can see here the net injection to the grid. We can see that the battery is discharging at the start of the day and at the end of the day, and that's probably charging during solar hours. So it is using all this curtailment to charge the battery during the solar hours and then discharging it here when the PV production stops. So there's more things that I don't have much more time to show you, but yeah, this is a super powerful feature. You can define infinite amount of scenarios here. You can maybe allow to charge from the grid, or maybe you can set different prices. Maybe you don't have a PPA anymore for the PV plant. Maybe you have variable prices. You have a merchant PV plant, so maybe you want to choose variable price, or maybe you still have a PPA for the PV plant and you are selling fixed energy at fixed price, but you want to use you want to go to the wholesale market with the BESS, with the battery, and do a merchant battery system. So then you can define also different prices for the batteries, and this way you can start mixing different inputs with different scenarios and see the use case that better fits your needs, and then optimize and iterate over the different cycling, degradation, and different scenarios. So this is everything that I wanted to show you, and now we can continue with the Q&A session. So let me go check the questions. Moment here. You can now write your questions in the question box. Okay, so the first one from Charles Opata from Kenya Electricity Generation Company. How do we optimize the sizing of the BESS? So this is a super good question. The answer is it depends. It will depend in what market you're trying to develop the battery. It will depend on what's your needs. It will depend on if you're trying to maybe do big saving to analyze or to cover a load, or if you're just trying to make a profit out of your battery and you're going to sell the energy in the wholesale market, or maybe do ancillary services with frequency control and different things. So it will really depend on the market and on your needs. But I think with rated power, you can try these different scenarios and really iterate over your system, this way optimizing and see what really is the optimal sizing of your battery system, because it will depend in really a lot of variables. If you have like the amount of curtailment that you have, if it's a hybrid system, the PV production. So yeah, it's really difficult to say. Okay, so Diego Lobo is asking. Well, thank you also for joining, Diego, and thank you for the question. He's asking if I could please describe how the energy price forecast file has to look. I don't have any. mm I don't have any here that I can show you, but if you, when you're going to upload the file, there's a link there to the help center, to the Rated Power Help Center, and you can download a template from there, and you can see it's really a CSV file with the hour and the price basically. So you can download a template for there, and from there and check it. It's in our web page. Maybe we can share with you the link after the webinar. Mm. So Andil is asking if this is only for simulation or it can be used for monitoring production and financial performance when the plant is running. This is only for simulation, design, profitability, so more like in an origination phase. It does not work for operation, although really if the financial inputs are right and they are correct, you can actually see what is going to be like the decisions of charging and discharging, because the model really works as an optimizer that you would use in the trading desk when optimizing the charge and discharge. But it does not work as an operational software, let's say. So Jonas is asking if this is only applicable to the Spanish market. It is not. I was doing the example with the Spanish prices, but obviously you can design your plant, your PV and battery plant at any place really, like all over the world, and the market prices will depend on the prices that you are uploading. So if you're I don't know, in Germany or in Australia, you can upload the wholesale market of market prices for those countries and really analyze the plant wherever it is. Um, are also revenues from ancillary services taken into account in the total revenues? No, we're currently just considering wholesale market prices, but we are studying the ancillary services option too for the future. Also, Antonio Saponaro just asked the same question about the ancillary services. It's not currently available, but we are studying it and we will add it for sure in the future. Ariana, it's asking if the degradation is linked to the number of cycles and the depth of discharge. Um, it is it is not like we just have it as an input. Uh, the degradation is obviously linked. So if you're changing the number of cycles and the depth of discharge, you should also be changing the degradation. But we leave this as an input for the user because we know that this degradation will vary differently depending on the manufacturer that you're using. So we leave this as an input for the user so they can change them accordingly to what the manufacturer is it's basically sharing with them. Um, Famke is asking, why would you recommend RatedPower's best capabilities in comparison to other tools on the market today? Well, we've spoken about the benefits. I think it's a really intuitive tool, easy to use. Uh, with few inputs, you can really change completely how the model is working. And also, by using this optimization approach, you're really mimicking the very complex trading algorithms used. So you are getting really realistic and accurate results out of it. So that's a great point. So Kim is asking what's the constraint optimization algorithm and what is the objective function if it's the profitability. Uh, yes, the objective is to maximize profitability and the restrictions are based on the system that the user is defined. By the way, Kim, if you want more details on the optimization model, you can change. You can sorry, change. You can check our methodology for BESS. Is really all very well explained and detailed in there, and it is accessible through our help center. Eduardo, it's asking if we can have some solutions with and without the grid. That's correct. Well, that's correct in the scenarios when we have a hybrid system, right? Because if you have a standalone system, the only way to charge and discharge the battery, well, the only way to charge really the battery is by connecting it to the grid and consuming energy from the grid. So in that case, there's no more to it. Like you have to be connected to the grid. But in the hybrid systems where you have the pre-production available to charge the battery, in those cases, you can deactivate the charging or consuming from the grid, so you don't have expenses in that regard. It's only everything comes from the PV. Uh, Venkat is asking if the augmentation capacity can be considered in this analysis and if you can get the results out of it. Not currently. If you're doing augmentation like at some point after the first year, let's say. Oh, okay, lights went off, sorry. So you can maybe consider overpowering at at the start, but we currently don't consider augmentation or revamping at the middle of the simulation. But for sure, this is something that we will consider for the future. Samuel is asking what is the price for BESS standalone. You can probably check for standalone. So I know for Spain, the more or less the figures right now are around 300 euros per kilowatt hour for 2-hour systems, and around 260 euros per kilowatt hour for 4 hours systems. But I think this is for hybrid systems. For standalone, maybe a bit different, although it shouldn't be. But you can check the our source for the energy for the battery prices in the in this analysis of the National Renewable Energy Laboratory, the NREL. You can type Google NREL battery energy systems prices or whatever, and you'll see it. And Samuel again is asking if I input figures which result to poor profitability, like in our example with these panel prices, for example, does the software provide recommendations to achieve profitability, or does the user have to play around with the figures each time to see what the profitability is like? So is the user the one playing with these inputs to see really what's the best profitability that you can reach. It's not maybe not super clear at first, like what's going like on like in what's the profitability higher or lower, but usually yeah, you'll get the hang of it as you start changing the supply hours and maybe the cycles too. Usually nowadays, I would say that 2 and 4 hour systems is where's the most profitable, but we're seeing in Australia and more developed markets, they're going already for like 8 hour supply the duration systems. So yeah, maybe play around with those inputs and see. Okay. Let's do a couple more and let's close. So another one from Samuel is asking if the system is capable of simulating peak shaving to better understand the best capacity utilization. So currently, peak saving, no, you cannot do peak saving. Currently, we just do energy arbitrage. For peak saving, you'll need probably to upload a load curve, right? Like a consumption curve from the grid, which you can not do currently, but for sure we will add it in the future because this is something that we're seeing is highly requested. Okay, Toby Foster is asking if we uh, uh, consider how vanadium flow batteries with unrestricted cycle duration and no degradation impact the modeling presented on best arbitrage strategies. We don't have like different types of batteries, so you cannot like define, let's say, the type of battery that you're using. but you have the inputs for the degradation and the end of life. So if these vanadium flow batteries, they don't degrade at all, and you have unlimited cycles that you can do, and you can really set the degradation to 0, the end of life to 0 also, or to the minimum, which I think is around 50 in the software currently, and run the software for as much cycles per day as you can, and see what's the output there. Okay, last one. Ismail is asking, well, thank you, Ismail, for your question. If you already have a PV design, if you can do simulations for BESS too, or if you need more license. No, if you have PV design, you can do also BESS simulations. Maybe I can show you super quick, because this is really easy to do. So if we go back to the main page here, where you can click on new design. Here, when clicking on new design, you can choose PV design or standalone. If you're doing hybrid, you choose PV design and then activate the battery system. If you are doing standalone, you click here in standalone and you start your new design from scratch. So I think that's everything for today. So thank you all for joining. Thank you for the questions. There was a lot of them today. Super glad to be your host again today. Remember that you have a Pulse ticket still available. And yeah, hope you really liked it and you continue to follow us in this content. So thank you and bye bye.